everyone, welcome to the second part of our lab on external switches. In the last part, we went over why switches are useful, and went in depth into read relays. Make sure to check out the previous part if you haven't already. In this part of the lab, we're going to be going over MOSFETs. MOSFET stands for Metal Oxide Semiconductor Field Effect Transistor. That's quite the mouthful, so we're just going to use the abbreviation. MOSFETs usually come in two modes, enhancement mode and depletion mode. We'll be going over enhancement mode MOSFETs. These are easier to use with the Arduino than depletion mode. We won't go in depth as to why, but a little more information can be found in the PDF for this lab. Essentially, enhancement mode MOSFETs are used as digital switches, whereas depletion mode MOSFETs are generally used as load resistors. We'll be using both NMOS and PMOS transistors in this lab. NMOS and PMOS transistors are very similar, but have several distinct differences that will affect how we use them in our circuits. We'll begin by going over some facts that describe both types, before delving into their differences. NMOS and PMOS transistors both have three terminals. They are the gate, source, and drain terminals. The gate terminal is what controls the MOSFET. The voltage at this terminal will control whether or not current can flow between the source and drain terminals. More specifically, the gate to source voltage, VGS, or the voltage at the gate minus the voltage at the source, needs to cross the voltage threshold, VT, for the transistor to allow current to flow. There are a couple of important differences, however. You may think that with terminal names like source and drain, that the current should flow from the source to the drain. This isn't always the case. In NMOS devices, the current flows from the drain to source. In PMOS devices, the current does flow from the source to the drain. Another difference comes from the relationship between VGS and VT for NMOS and PMOS. For an NMOS device to allow current to flow, VGS must be greater than VT. For PMOS, VGS must be less than VT. Also, PMOS devices usually have a negative VT, and NMOS usually have a positive VT. These differences greatly affect how we will use these devices in our circuit. We will use PMOS in order to pull a voltage up to some value, and NMOS in order to complete a circuit to ground so that current can flow. Let's go through a thought experiment to find out why this is. The PMOS source is connected to a 5-volt line, the drain to an LED circuit, and the gate to a digital pin on the Arduino. For the PMOS device we're using, the VT is negative 2 volts. Thus, VGS needs to be less than negative 2 volts if we want the PMOS to allow current to flow from the source to the drain. If the digital pin connected to the gate is high, at 5 volts, then VGS is equal to 0, which means that the transistor is off. If the pin is low, at 0 volts, then VGS becomes equal to negative 5 volts, which is lower than VT, so current can flow. Now we have a different PMOS circuit, with the PMOS source connected to the output of the LED circuit instead of the input. The drain is connected to the ground pin on the Arduino. This circuit will not work. Can you see why? When the digital pin is high, VGS will be at 0 volts. This is because no current can flow through the system, so no voltage is dropped over the resistor or LED. Thus VGS is about 0. When low, the circuit still won't work as expected. The exact equations and reasoning behind this are a little complex, so we'll try a simpler explanation. Let's pretend that the transistor is fully on, and model it as a resistor of about 0.05 ohms. This isn't an unreasonable assumption, if the transistor is actually fully on. Now, almost all of the voltage is lost across the LED and resistor due to their much higher resistance than that of the PMOS. That means that there's almost 0 volts to be lost across the 0.05 ohm resistor. Therein lies the problem. VGS needs to be less than VT to operate, and this implies that VGS is about 0, which is too high. This is impossible, so the PMOS can't actually be doing this. In reality, the transistor is only partially on, that is, only allowing some of the current to flow. The actual resistance of the PMOS is far higher than we said, so barely any current is flowing through the circuit. Thus, the LED will be far dimmer in this circuit than in the previous one. A similar thought experiment can be done for NMOS transistors. If you did that, you'd realize that NMOS doesn't have a problem with pulling a circuit down to ground. but they're terrible at pulling a circuit up to a voltage, which is the exact opposite of PMOS transistors. We recognize that this explanation may be a little confusing. We recommend reading our lab document, or researching more online for additional help. However, you don't need to perfectly understand this in order to use PMOS or NMOS transistors in your circuit. If you simply memorize that PMOS are good at pulling up to a voltage, and NMOS are good at pulling down to ground, you'll be just fine. Now we'll actually build a circuit that uses an NMOS transistor to turn on and off an LED. This is very similar to what we did with the read relay, except this time we're using an NMOS transistor. This is the circuit we're using to demonstrate how the NMOS transistor works. We have a line going from the 3.3 volt voltage pin to the positive lead of the LED. The other end of that LED is connected to the 1 k ohm resistor, and the other end of that resistor is connected to the transistor. The NMOS transistor has 3 pins, one for each terminal. From left to right, they go gate, drain, source. That's why we connected the resistor to the drain terminal, which is the middle pin. Remember that the current flows from drain to source through NMOS. We connected the gate pin to D2 on the Arduino, because we want to be able to turn the transistor on and off from our Arduino. We connected the source to ground. Thus, when the transistor is on and current can flow, current will flow from the LED circuit through the resistor to the drain to the source, and then to ground, completing our circuit and turning on the LED. Now let's go over the code. This is the exact same code that we use to control the read relay. If you're confused on how it works, make sure to check out that part of the video because we go over it pretty thoroughly. As you can see, the circuit using the NMOS is working correctly. The LED is flashing on and off on an interval of 1 second. Now let's go over how to use the PMOS transistor. This is the schematic for the circuit using the PMOS transistor. The PMOS device has the exact same pin layout as for the NMOS device. That is, pin on the far left is the gate, middle is the drain, and the far right is the source. We connected the gate to D2. We connected the drain to the positive lead of the LED. And we connected the source to the 3.3 volt voltage line on the Arduino. Once again, the other end of that LED is connected to the 1 k ohm resistor, and the other end of that resistor is connected to ground. Let's move on to the code. Once again, we've used the same exact code. Now let's see what it looks like when our circuit is operating correctly. As you can see, the PMOS transistor is working correctly. The LED is flashing off on intervals of 1 second, just like I did with the NMOS. That's it for this lab. We hope you enjoyed this tutorial and learned a lot. If you have any questions, make sure to leave them in the comments below. Also, if you enjoyed the video, make sure to like it and subscribe to our channel. If you have any recommendations for future videos we can do, or ideas for what we could show during our videos, also make sure to leave those in the comments below. Thank you, and see you next time.